Unit 7, Tutorial 1, Part 2, we are going to continue on with this idea of waves, and we're going to look at wave phenomena. So we're going to look at reflection, refraction, and total internal reflection. So we are going to look at what happens when a wave encounters a boundary, like a shoreline, a wall, or another medium. And several things can happen. The first thing that we're going to look at is reflection. So waves are reflected when they encounter a surface and bounce back. In other words, they don't enter the surface, they are reflected or bounced back. Light reflection is the entire reason we can actually see anything. When we're talking about reflection of light, light behaves as a transverse wave, and light reflects off a mirror, or your voice reflects off a wall. They always reflect at an angle depending upon the angle you're hitting at, like a tennis ball off a wall or a squash ball or a ping pong off a paddle, that sort of idea. So law of reflection is that the angle of reflection is going to equal the angle of incidence, which I'll explain in this diagram. So if we have an incident ray, so this is a ray coming in, picture this as a light ray, for example, and it hits a surface. You are going to have an angle made between that angle of incidence, so the incident ray coming in, and a normal. A normal is a line that runs perpendicular to your surface that you are reflecting off of. So you are making an angle of incidence between the incident ray and this normal. Your ray is going to reflect at an angle equal to the angle of incidence. And we're going to call this the angle of reflection. So you're going to get a reflected ray that's going to bounce off that surface at the same angle to the normal as the incident ray. You can have different types of reflection. This isn't really tested, but you can have specular reflection versus diffuse reflection. Specular reflection is when you hit a smooth surface. So all of your parallel light rays that are coming in reflect parallel as well. So if you picture all the normals here, all the normals are perpendicular to the surface, and the surface is all flat, so they're all the same. And you can get this beautiful, symmetric, perfect reflection. The only problem with this is that they reflect so straight out that if you have someone standing a little off to the side, they're not going to see the reflection. Versus a diffuse reflection, if you have a broken up surface where you get your normals at different angles from each other, that means that your reflected rays, even though they came in parallel as incident rays, are going to reflect at different angles away from each other. So they're not going to be coming out parallel. The downside of this is you don't get a beautiful reflection. The plus side is that eyes at every position can see reflected light. All right. So when we are describing the path a ray travels, we can talk about them being parallel, which means they will never meet. We can talk about them converging, which means that they will come together at a specific point. Or we can talk about them diverging, which means that they are going away from each other and will never meet. The first type of reflection we're going to talk about is reflections off of plane mirrors. So these are flat mirrors without any curves. I have a link here for how to draw a ray diagram for a plane mirror, and I will put this into the description of the video, but I'll also put them into your email. But the way that you're going to draw a ray diagram for a plane mirror, and this is to determine where your object is and what it looks like, is you're going to pick a point on the top of the object, and you're going to draw at least 2 incident rays traveling towards the mirror. So if you look at this diagram here, I have an object, which is here. And I'm always going to have the object sitting on this line, because wherever this line is going to be the bottom of your reflected image. And then what you're going to do is draw at least 2 incident rays and see what happens to the reflected rays. So for example, I can draw one parallel to this flat line on the bottom, which is going to hit your beautiful flat surface. Now the angle of incidence to the normal is 0 because it is on that normal line. And so your reflected ray, which I'll put in red, is going to bounce back. Now this line isn't going to help you at all yet, but it will in a little bit. So then you're going to draw another incident ray. So you're going to draw an incident ray. The easiest one to draw is from the top of your object and then having it hit the mirror where your mirror hits the bottom of your image. And so this is going to be your incident ray. This is your angle of incidence. And then you're going to have a reflected ray that whatever angle this incident ray came in on, you're going to make it equal to this angle of reflection. And you're going to reflect your ray. Now, what I want you to notice is that this ray up here and this ray down here are never going to meet each other. We say that they diverge from each other. And so I could never have them meet at a point. And so what I want to do is figure out how I can make them meet. So I should go through these step by step. So step one was pick a point on the top of the object and draw two incident rays traveling towards the mirror. Done. Step two was that once these incident rays strike the mirror, you want to reflect them according to the laws of reflection. So you want your angle of reflection to equal your angle of incidence. Done. Step three, if the reflected rays converge, mark the top of the image where the reflected rays converge and draw the image. Well, these are diverging. They're never going to meet. So instead, if the reflected rays diverge, you're going to mark where they would converge as a virtual image. Now, virtual image, we're going to talk a lot more as we go along, but a virtual image is something that appears behind a mirror. So if these two rays were to converge on this side, let's say they met here, we would say that this is a real image because it's existing on the real side where the image is located. If your rays diverge on this side, but if we extend them to the other side of the mirror, which is behind the mirror, which makes no sense, you'll notice that these reflected rays on the other side of the mirror, they converge. And so what's happening is that you're getting this image on the opposite side of the mirror where the reflected rays are going to converge. And so the image, this is to the top of the image because that's where we went from. So these light rays are going to converge at the top of the image. So we're going to draw from that center line to there and say that this is my reflected image. What do you notice? Well, how does the size of the reflected image compare to the object? It's the same. Is the image upright or inverted? Well, it's upright. And if the object is 50 centimeters in front of the mirror, where would the image be located? It would be located 50 centimeters behind the mirror. Which side of the mirror do the reflected rays converge on? Behind the mirror. So this we're going to identify as a virtual image, but we're going to talk a little bit more about what a virtual image is for now. But what I just want to talk about is this process of discovering where does an image form using a ray diagram. So again, you draw two incident rays from the top of your object. You draw the reflected ray following the angle, the law of reflection. So the angle of incidence equals the angle of reflection. And then you see where will they converge. If they converge on the same side as the object, or do they converge on the opposite side of the object? And we'll talk about what that means. So when you're forming an image, when light reflects or refracts, images are always formed. But you can describe an image in the following way. You can talk about their size. So for example, this one, we had an image that was the same size. We can talk about their attitude, so whether the image was upright or inverted. We can talk about their location, which we won't do very much because we'll just talk about closer or farther. Because there's calculations that we can do, but we're not going to. And then we talk about whether it's a real or virtual image. Now, before we move on, I just want to talk about the fact that this is a plane mirror. So a plane mirror, you're looking at your reflection in the mirror. So you can practice this. Stand in front of a mirror. What does your image look like? Move back from the mirror. What does your image look like? So you'll kind of get a sense of what we're talking about here. But now I want to talk about this idea of real versus real versus a virtual image. A real image is that the light rays after reflection or refraction are going to converge. You're going to get an actual intersection of the light rays. So for example, if you had a ray come in and then come out, and you had another ray come in and let's say come out, and you had this converging on the same side as your image, you're going to get a real image, which means that if I held up a piece of paper, so let's say I had a candle in front of a mirror, which one of these videos that you watch will actually do for you. But if you put a candle in front of a mirror and you held up a piece of paper on the same side as the candle, you could get an image of that candle to appear on the piece of the paper. But what you're going to notice is that it's going to be an inverted image, meaning it's going to appear upside down. Versus a virtual image is when we get this diverging of reflected rays, but they appear to converge on the opposite side. So you get this imaginary intersection of light rays. It's not actually happening. The light rays aren't going through the mirror, but we are forming an image behind the mirror. You can't form it on a screen. You can only see it in the mirror. Concave, convex, and plane mirrors always can form virtual images, and they're always going to be upright. They're going to be the same as the image that you are taking a reflection of. So what we're going to do is we are going to practice drawing a ray diagram for a plane mirror, and then we're going to talk about some features of the image that is formed. So I thought that I could use my done key for this, but apparently I think, unfortunately, I may have scanned in the wrong key for you guys. So hopefully you are watching this video and not trying to go off the keys because they might not match. So I'm going to try my best because it's really hard to draw straight lines on this thing, but hopefully I'll talk it through well enough that you'll know what I'm talking about. So what did we do? Step number one was we were going to draw two incident rays from the top of my object. So I'm going to draw one that is perpendicular to my reflecting surface, and use a ruler, please. And then I'm going to draw another one that's going to hit the mirror where the mirror hits the bottom of your object. So there. These are my two incident rays. Then I'm going to draw two reflected rays. So I'm going to take another color, and my first one's going to be easy because it's going to go back along the same path because my angle of incidence is 0, so my angle of reflection is also 0. Then I'm going to picture this having an angle of incidence here. So whatever this angle is here, and I'm not expecting you to measure it. I mean, if you were going to be perfect, if you feel like it, please do measure, but we're just going to kind of eyeball it. So we're going to say that this goes something like that. So this angle of reflection is going to equal that angle of incidence. And what I want you to notice is that your rays, your reflected rays, are diverging on the same side as the image. So what we're going to do is extend these reflected rays through the mirror. And so you're going to take the first one and just keep it going and make it really long. And then you're going to take this one and you're going to extend it until it hits the other one. And the intersection point of these two reflected rays is going to be where your image is formed. And for a plane mirror, you are always going to get a virtual image. So it's going to be an image formed behind your mirror. So we are going to get a virtual image, which is upright. When you look in a mirror, you want to see yourself upright. It would be weird if we looked in a mirror and saw ourselves upside down. So a virtual image is formed, which is upright, and it should be the same size. I'm not going to talk about location. That is, again, something that we could use a formula to calculate, but we were trying to really just make this a pretty straightforward unit. All right, uses of plane mirrors. You can use plane mirrors to see around corners. You can use them for periscopes, which is this figure at the right. So for example, if you were underwater and you want to see something on the surface, dental mirrors, kaleidoscopes, telescopes that are flat, overhead projectors, and really looking at yourself. All right, so that is the end of tutorial 1 part 2. We'll see you or talk to you soon.